Hi everyone, thank you for joining me in this session today. This is 15 Days of SQL and I am Akriti, a data analyst in the AI domain by profession, and I'm also a part-time content creator, primarily on Twitter. I also write my blogs on Medium. You can find all of the links on my channel. Just very recently, 2 weeks ago, I started my YouTube journey, and I'm really grateful for each one of you who have joined me here in my initial days. In 15 days of SQL, what we have done starting 15th of September is, for every day we had a tutorial, a blog written by me, and this 30-minute live session at the end of the day. When you're done with reading the material, studying, getting the concepts, and so we review them together here on a live session so you can clarify your doubts or get started with the practice part of things, because here we don't learn by just going over the theoretical concepts but actually implementing them through problems in a coding environment. Thanks for joining me, and let's get started. Today we'll be focusing on SQL data types. The link to the tutorial is added in the live chat. You can check it. I highly recommend opening the environment on your workstations as well. And so this is not just a theoretical lecture where you're just getting the information through audio or video. I want you to actually put your brain to it and practice the questions side by side. Today we'll be focusing on data types. Now, what are data types? So you have certain data stored in your tables. Within table you have different columns inside which there is some data stored. Okay. Now that data can be a number. Primarily without any SQL knowledge, you can still divide it into three main categories. That is number or numerical data 1, 2, 5, 7, 38.6. Then the second part is the text data, right? It can have numbers, it can have name of cities or name of companies, name of people. It could have anything that has got to do anything with characters, your alphabets, or a mixture of any character is called a string. That string data is a different data type. Okay. Next type of data is dates. So when we have such stored data, we have dates everywhere, especially in time series data, or in general when data is stored, people generally prefer having the timestamp of that whenever that data was collected or that purchase was performed, that entry was recorded. The timestamp really helps with ordering things chronologically, or if we have to group by a number, by the month or by the year. So in order to get a brief overview of data, dates are very necessary, and that's an inherent part of the SQL ecosystem. Three main things you can see from the very surface level: that we have numeric data, we have data which is in the form of text, so string data, and then we also have data in the form of dates, timestamps, that is of the date. These are what data types define. So when you are building a database, creating a table, you need to explicitly tell SQL which column would be storing which type of data. Okay. So if the type of data which you're trying to insert into SQL does not follow that format, suppose I have said that some part of the data would be dates, okay, and I'm entering a number there. So SQL will throw an error and it won't let you add that data point inside your table. Why is all of this necessary? Data types help SQL with trying to determine that what sorts of function would be applied on this data. In just yesterday's session, we discussed a lot about string functions. If you've not checked the session, it is linked in the 15 Days of SQL playlist under the episode 9, string functions. String functions, be it coels or trim, left, right, concat, all of them were very specific to string type of data. You cannot perform that operation on numeric data. How was SQL able to know that, okay, this is the type of function which I should be performing on this data? Because when the columns were defined, it was specified to SQL that this column would have that sort of data type in it. Okay, it was specified that it would be some sort of string, so moving ahead you would be applying string functions on that type of data. This is where data types come into play. The data types help SQL understand what kind of data it should expect and then what kind of functions it should apply on that data. Okay, these are the kinds of data types formally which we have. So there is string, which we were saying types of text. And how is it defined? So it is called varchar. What is varchar is? It is variable characters. Okay, varying characters. So in the same column you can store a string with the length 30 and you can also store a string with length 40. Okay, so the length of the string would change, but it has to be before 1024 because that is the maximum field length for varchar. Varchar is variable characters. You can store as many characters as you want till 1024 and it will take the shape of those many characters. You have to define what is your maximum. The maximum defined by SQL is 1024, but you feel like if it is just a name, okay, and you think it can be stored within say 20-30 characters, so you can save the space. Moving ahead, we'll know how to fine tune our data, how to optimize SQL queries. So there speed is a very big thing, and speed is facilitated well only when the data is stored properly. If data is stored in smaller chunks rather than allocating a big chunk of memory for a small piece of data, obviously the data processing would be faster and your queries would be returned faster. So this is varchar. Next is date or time. It is stored as the data type timestamp. It can have the format of year, month, date, and then the timestamp would go as hour, month, and then second. So the data type timestamp would store the date and time, and it would store all of the information regarding what year, month, date, hour, minute, and second the operation has been performed. Next is the number, which we have been using a lot in the past 10 days of this 15 days of SQL challenge. Numbers, they can be integers like 1, 2, 3, or they can have decimal places. So what SQL says is I want till 17 significant decimal places is what it will hold, and that is called double precision. Next is Boolean. Now this is new and not very frequently used, especially in the data sets which we have dealt with till now. However, it is an inherent part when you're dealing with conditions, right? Every time we had put a where condition or whether we were putting a condition in the case clause, we always said if the condition evaluated to true. So what did we mean by that? A condition, once it evaluates to true, it returns a value Boolean, true or false. So what Boolean is, it is either of the two values which is true or false. So Boolean can only store two values which is true and false. When dealing with conditions, a lot of Boolean values are returned depending on how the condition evaluates. So that's something you could relate with, even though we have not formally seen Boolean type of data in our data sets yet. Now what happens is sometimes we import data from different sources and the data is not very clean, the data is not well casted, so they have still considered data like date and the timestamp, the whole timestamp, as a string, okay, because it still contains a list of several characters and symbols, alphabets. So the data by default is considered string, okay. Now what I need to do is, I know that if it is a string, I cannot perform the date related functions on it, correct? If it is a string, how would I be able to perform the date related functions? Since if it is a string data type, SQL knows that the only type of data which is stored inside that column is string data. And for string data, it already has a long list of string functions, which only can be implemented on that data. So it won't let you perform the difference of dates or extract the year, month, or date as you want to. That is not something we would want, and that would pose problems as we move ahead. So that is not recommended at all. It is always recommend is one of the foremost steps in the data cleaning process, that you start with putting the data types in a right format. First of all, whatever your data is, it should always have the correct data type. What is the data type? It is the type of data stored in a particular column, and it should always be in the correct format with what the data is conveying. Otherwise, performing functions on that particular data would be difficult, and it will throw error, and we won't be able to utilize all of SQL's functionalities on that data. Hi Anand, so we'd be using varchar here. Varchar is what we'd be using for now. Okay. Now, how do we change a column's data type? Suppose we have imported and it is string, as we discussed earlier. How do we convert it into, say, integer or date? What we'll say is, we'll say cast column name as integer, okay, or column name dot dot integer. Similarly, if you want to take it as a date, so you'd have to say cast column name as date, or you can write this shorthand as column name : date. So there are certain data types which are stored maybe by default as strings, and it is very essential to cast them. Cast is just a word for changing the data type or something. So you can cast them into their corresponding data type using cast operator or double colon. Okay, let's try a practice problem, and what it says is convert the funding total USD. So just by looking at the problem, we know that it is a number, right? Funding total is a number, and founded at, I am assuming would be a date kind of column. Let's see. Columns in the tutorial Crunchbase company's clean date table to strings, okay, using a different formatting function for each one. Okay, so we have to change this to string. Let's see. If you have any ideas how we can do that, feel free to add them in the chat box. I would be grateful to be enlightened by you all. Yeah, the workspace is ready. So what we were told is we need to convert certain columns, but we'd first be looking at what the data actually is. This is highly recommended. You should be getting an overview of what data are you dealing with. Okay, we have permalink, name, homepage, category code, funding total. Okay, I assume it's a number because it's I mean currency. So, and then what did we have? Founded at clean. Yeah, founded at clean. They all have to be changed to strings, correct? Table to string, varchar format. Okay, what they said was funding total USD, this column. So what we do is we'd make use of the cast function. What cast function does is it will take a column name. The column name in this case is funding total USD, and then it will say as, and then the new data type which you want. So I want varchar. And since this is varchar is used to store strings, always remember that. So I am assuming all of it has 7 characters, but it could be more, so I will be generous and let it have 15 characters. If it has less than it, it would shrink itself. If it has more than it, then it will cap at 15 and it won't have any characters after the length 15. But I feel 15 would be good enough to, I mean, who has a 15 figure funding total? Nobody, right? So this is one way to do it. They specifically ask that they want to convert the formats in 2 different ways. So using a different formatting function for each one. So we'll be using founded@clean and changing it to varchar again. But this time we'll be making use of the double colons. Okay, and then again varchar, but varchar what? So I think it is in the YYY format. So I think it will take a total of 10 characters. I will give it 12 in case there's some space. And yeah, so we made use of cast, and we casted our funding total USD as a varchar, which is a string, and then we used a different way of casting, which is using double colons, and then we casted our founded@clean to varchar. Let's see if it works. It gave us some result. Let's compare it with the solution, then we can go ahead. If any one of you have any queries regarding this, feel free to add it in the chat. Cast funding total as varchar. Okay, they did not even ask the the length. You can just write varchar and it's good enough. Great. And then they have used a similar technique to change founded@clean to varchar again. So yeah, we're on the right path. Let's get. Now the next part is, now that we know how to convert our data into its correct format. Now how you should be making use of that format or utilizing all of its dependencies and functions. So let's get started. The lesson on data cleaning provides some examples on. Okay. Now what you'd be using a lot when dealing with dates is the extract function. A lot of time what happens is, you're not as interested in the entire date, but you are interested in what is the monthly sales, right? What is the yearly sales? And how do you calculate that? You'd be calculating that using a specific part of the date, not the entire date, a specific part. Whenever we want to get a cumulative thing, so if I say I want for all of the dates occurring in the month of February, okay, and I only have the date column at hand to provide me that information. So I would want to obviously group here, because the task at hand requires us to deal with multiple rows and then perform some aggregation over it to give us the total sales. Now that we know that, okay, we have to perform a grouping, now on what basis should we have the grouping? So that grouping will happen for a specific part of the date, and that specific part of the date is extracted using extract. So I will say select and we'll say extract. And what extract does is, it will take whatever you want to say, year or month or day, you can say that. Extract in the round brackets, you can say year, date, month, hour, whatever you want to, from your column name. So I think it's founded@clean, okay, from, then Crunchbase, clean date, I think. Company's clean date. That's what I think the table is, yeah. Oops. PG catalog date part unknown does not exist. No functions matches the given function argument. Why though? 1 second, I'd have to check with the Postgres number which it is. It should take that. Let's put the year as. Let's see if it works. Maybe the founded at clean is not actually timestamp, so I'd have to make it timestamp. Now it is running. Okay, so this is a very excellent example of why data types are necessary. So what happened here originally, why the function was not working, is that founded at clean was not casted as something which stores dates and times. So extract only works on date time formats. So it will extract year, month, day, or it will extract the week, second, the time zone, or the quarter, the minute. It will extract everything, but it only works on the date time format, which is stored under the data type timestamp. So I said that I want to extract year from founded at clean, which stored all of my data for dates. But actually how it was stored in the table was not in a timestamp format. So I had to here implement the previous concept which we just learned, how to cast certain columns to a different data type. So I just casted it to timestamp, and now the function is working well and fine. Now you see, let's as y, and I don't want you to have the blank things, so I'll say y is not null. I want to get rid of the blank cells, so I will say y is not null. I am saying it is y. Oof. It is not letting me use the alias, so I'd have to write the whole thing again. So now you see all your blank cells are gone because it checked whether it is null or not. When it is not null, then only the condition is evaluating to true and your query is filtered out, your particular row. And if the condition evaluates to false, that is in case that particular row entry is null. So we are leaving it out, we are discarding that row itself, and we are not including it in our query result. Now you see you just got the year part, so I can do similarly for month if I just want the month. This was how originally the data was stored, you're seeing 2013, 2011, the entire date is stored in the YY MMDD format, I think. See, now you're able to get the value of, like, 1 represents January, 2 represents February, 7 represents July. So you're getting the number of that particular month. What else do we want? If you want the day, you can also have that. Next we'll do for the decade. Decade and century can also be extracted as if we have any data. I mean, we might, but not certain data analysts. I mean, I don't think that the data from previous centuries would be digitalized, at least, but maybe. So now you're getting the dates. Next, let's extract the decade. The syntax remains the same. You say extract and then there's a round bracket. Inside you put whatever part of the date you want to extract. It can be day, month, day, decade, century, year, whatever you want to have. You can also have the time parts like hour, minute, seconds, milliseconds, and it will extract that part from. You'll have to specify from, and then make sure that the column which you are specifying after from is in the data type of timestamp. Otherwise, it'll be no harm to just cast it to timestamp. Now we have the dates. Let's get the decade, and then we'll be done with our little fun experiment. Okay, so month name cannot be extracted because it is not saved that way in the month, like in your data. So it'll always give you the value, the numeric value from 1 to 12. You cannot get the month name as such. However, you can perform a case. I'll recommend you check out the 5th or 6th part in this series. It is case. It is the 6th episode. What case does is it'll perform a condition over it. Okay, so you can say that if the extracted month part is equal to 1, then the value would be January. If the extracted part is 2, then the value would be February. And then for 12 conditions, you'll be able to get the month name as such, but you'd have to specifically write something. Yeah, I'm not making complete. Okay, yeah. So this is the 2010 era. This is the 2000s era, and this is the 1980s. This is the I saw 1990s also, yeah, 1990s. So now you see it is giving you the decade. Pretty interesting if you ask me. I really like this about SQL. I hope you are implementing it side by side. Maybe not as crazily as I am doing because I am geeking over the date types a lot. But make sure you write at least one SQL query in this entire session every day, and you'd be amazed at how much you've achieved looking back after this 15 days. That's highly recommended from my side. Okay, enough of TED Talk. Let's get back to what we wanted. So another very useful function here is now. What now does is it will return the exact time with the exact date, time, seconds, till the precision of seconds, I think, with the time zone that is occurring right now. So I think it will change depending on what time zone you are performing or triggering this now function from. Let's see. We'll talk later. Let's implement it first. So select now. You don't need to specify a table name because for now you don't need a table. You're not fetching it out of some database. You are getting, I think it gives in the GMT 00 format. So the time zone cannot be altered. I feel if each one of you write this, please can you run this select now query and let me know in the chat box. I feel everyone will receive the same answer with the same exact precision because it works with the GMT time and it is not customized according to time zones. I guess SQL is not as customizable till now. It will give only one value for all of us apparently. Okay, and now how this now is useful is, for example, you have been told that you want all of the queries which is say 1 year from now. So all of the transactions that happened for someone in the past 1 year, okay, you want that. So how would you compare it from now till the past 1 year? For that you need what is the time right now. and whatever is happening now, then you'd subtract every year with it. For that, we'll make use of another important concept called interval. Okay, so what intervals does is they are the difference from one date to the next date. They are the difference between them. So interval could be any span of time between two dates. This is very useful when you're trying to calculate within a certain range of dates, like what is happening every week, every past week. So for the past 4 weeks, for every week, what was happening. So you would get the interval of 1 week starting now. And how do you specify these? So you just use interval and 1 week. Or if you want to add something, for example, I wrote and the data has been entered, but I want to advance all of my dates with 1 week. So what I'll say is I'll take my data wherever it is stored in whichever column. I'll first of all cast it as timestamp because I don't want to encounter that error which I did earlier. And then I'll add interval 1 week. Okay, this can be 1 week, 1 year, 5 years, 5 days, whatever you want in simple plain English, but make sure your spelling is correct. Then you would specify it as a string, 1 week, 1 year, whatever you want to, and then it will simply add it. So interval itself is in a date time format, and it will perform the date additions or difference, whatever you want to, that will be performed. So for example, I want to get the time 1 week from now. So I can say that minus, let's see if this works or not. I have not, for and the difference between dates, I prefer date diff, which we'll be seeing. Let's see. Yeah. So from right now, what was the time 1 week ago? That is 17th of September, and since it's the GMT time, so it was 4:08 p.m. then. What was the time 1 week ago? So that I'm getting. If I want all of the transactions happening within 1 week from now, I can say that if whatever date information I have is within this period or is after this particular timestamp, I can consider it the recent week's transaction. Correct? Because this is the lowest bound I want. This was the time which was 1 week ago. Now all of the transactions happening after this would be considered in my current week. Correct? That's where intervals are used. Intervals are very heavily used whenever you want to consider everything within the last week, last month, last year, or you want to get it per week or per month. So you can either extract the week part from the date, or you can say if you have a particular thing that I want everything in the week of 1 week from 25th of December. So I will write 25th December 2022 and I'll add interval 1 week to it, and everything that falls within that time frame, that range, that interval would be considered, and the rest won't be. Interval is just a way to add, subtract, or perform any operations with an interval of time. It could take any value, week, days, months, years, but it is just a way of performing arithmetic operations in the date time format. So there are lots of differences, different functions available for dates. I'd recommend you check out the Postgres entire documentation for dates. The best one is date diff. You'd be using that a lot. But yeah, let's first look at the practice query. Write a query that counts the number of companies acquired within 3 years, 5 years, and 10 years of being founded in 3 separate columns. Now, how cool is that? Include a column of total companies acquired as well. Group by category and limit to only rows with a founding date. So we have a lot to process. Okay, but which particular thing are we dealing with? I'm not sure what are we dealing with right now. Are we still dealing with this? I feel if they're not specified, this is what we'd be dealing with. Let's first look at the data and see what we have, and then we'll not to get overwhelmed by this overly complexly written question and decode it one by one. Yes. So what we want was their founding date, correct? Because what it said, 3 years, 5 years, 10 years of being founded. So founded at or founded at claim. That's all there is. There was something called acquisitions also. Let's try that. Crunchbase acquisitions something. I'm not sure though. Yeah, there is some acquisitions clean date. They should have specified what do they want first of all. This has the acquirer name, region, acquired at, cleaned. Lovely. So we have the founded at date in a separate data set in the database, and we have the acquired at date in a separate table in the database. Lovely. Now we'd have to first perform joins. Joins are something which we looked at two episodes from today. So if that is something which gives you trouble, you might want to check it out. What do we need to join it with? The tutorial Crunchbase company clean date, correct? And how would we joining it? So we'll and let's give it an alias. So C for this and A for this. Why do we give an alias? Because we want to make our work easier when we are dealing with data later. So we'll say C dot company permalink is equal to this, because I feel when we looked at both of the, actually I did not feel we have dealt with the same database in the previous classes, so I know that the linkage between these two tables is the company permalink. Permalink equal to, what this will do is everywhere this matches with the previous table, some value matches with some value in the previous table, it is equal to, it will match those or join those rows together. Cool. Now we were given one more condition, that was that you only want to consider that rows which have a founding date. So good enough, we want founding date, founded at clean, we want it to be not null, so we'll say is not null, correct? We are done with this. Now to the part which they actually asked for. So we want to see how many companies were acquired within 3 years of their founding. Okay. So what we should do is, I think we'd be I have multiple solutions. I am not able to figure out which one would be best and more efficient here, because they have said that you want to limit some things. So what should we do is, first of all, we need to consider the interval. So within is what they said. But how can we count them is my cause of concern. Similarly, if you have any like solutions to this, you can feel free to tell me that. My way of doing this would probably have like a case statement and then counting it. But I'm feeling that must be a simpler, less complex way to do this, which would not require multiple conditions. But okay, let's first start with what we have at hand, and then we'll do what we want to. Okay? So what we want is, first of all, let's create space here because this is too cluttered. Case. What the case is that it is acquired within 3 years. So the acquired date should be within 3 years of the founded at date. So we'll say the acquired at cleaned should be less than or equal to case. For those of you who are not aware with the case statement, you can check it out. It was like 6th episode in the series. What case does is, depending on whether a condition is getting satisfied or not, it will add a value to a certain given table. So what should we do? Yes, we will say that if it is less than equal to our founded date, founded at clean, plus interval of what we wanted 3 years, within 3 years. So I will add whatever my founded at date it was, and then add 3 years to it. That is my upper bound, correct? That is the most that the acquisition date can go. Now if it is less than or equal to this, then you can have which means that it was acquired within 3 years. If it is more than that, then our question doesn't get satisfied. And since we want to count the companies, so we can just say count of this whole thing. Okay, and we will do the same for count of, we will do the same thing for all of our things, which is on the 5th year and the 10 year, I think. Oh yeah. Case contains one condition, and that condition would be, if it is satisfied, then we'll have one value. If it is not satisfied, then we'll have to give another value and then end it all. So here, since I want to count only the values which have been acquired within 3 years, I'll say that if it gets acquired within 3 years, then the value should be 1. Okay, because in the end I'm counting it. In place of count, you can also do the sum. So I am considering that company as 1, and otherwise, if nothing matches, this condition does not evaluate to true, I will simply give it a null or a 0. If I do a sum here, I'll give it 0, and then I'll end my case statement. Again, what case statement did was, it took a condition. In case that condition is true, then you give that particular row saying that okay, it was acquired within 3 years, so you'll give it 1, otherwise the row would be blank, and we'll end the case statement. Now you have an array of ones, correct? All of those ones would be counted, and those many, like 1 is getting assigned to only those companies which are getting acquired within 3 years, correct? So all of those ones would be counted, and they would be stored as the column name within 3. To save further problem, we'll just change this 5 years and this to 10 years, and within 5, so this will be within 5 and this would be within 10. And then finally, what the query asked was include a column for total companies acquired as well. So I think it can just be the count of all of the ones. Let's see. Let's first run this and then we'll have the rest of it. It also wanted us to group by the category. I'm not sure in which table the category is. I am assuming category code. What is category code? Let's see. We'll get category code also. C dot category code. Yeah. To just see what it is. Syntax error at or near then. Okay. Which then? Okay. Case, and then this is a condition. Oh. So what happened here was it was not able to see how to first add, since the operators have higher precedence over the arithmetic operator. The relational operators have a higher precedence, and we have not even casted it, so we need to cast it. So let's do it for all of them. Such things don't come up until you have actually run the query. So see, if I thought in theory, I would have thought I know everything about the casting and interval function, and I would have sat on my throne happily. But then when in practice, it would have struck me that, oh, I don't even know how to run it. It again has an error. Syntax then at or near then. Okay. Timestamp plus interval 3 years. Okay. What could go wrong then? Have I not written when? Yes, I have not written when. So as I said, that case follows a very specific format. It is case, when, condition, then, and after that we have multiple conditions. After the condition is specified, we say then something, some value. After all of the conditions have been listed, we say else. We give it the default value and we end the case statement. That's how it should go. But if you are panicking because of the question like me, then it would be error-endious, as it clearly was here. No, we still have something, but there's a new. We just have a new error. Now we have an even more new error. From tutorial, perhaps company permalink does not exist because in the name of the function is actually permalink, and I wrote company permalink. The name of the column in the company database is permalink and not company permalink. Yep, finally we have results. Now you see, for every category you have how many things were, how many of them were calculated, how many of them were acquired within 3 years, within 5 years, and within 10 years. We made use of that using a condition that the acquired at date is within or equal to an interval of 3 years, 5 years, or 10 years starting from the founded at date. We passed that condition to a case statement which returned 1 in case the condition evaluated to true, and nothing in case the condition evaluated to false. We ended the case statement and took account of all of those 3 values, which is 3rd year, 5th year, and 10 years. And then we were able to get what we wanted. I hope this went inside your head. If it didn't, I am really sorry. And please ask me in the chat box to go over it once again. And if you're done and this was in fact something which could go inside your head, congratulations, we are done for today. I hope this was an insightful session that added value to your data analysis journey. If you're looking for more such content, feel free to subscribe, turn my notifications on, the usual YouTuber outro line. And you can also connect with me on LinkedIn and Twitter so we can help each other out. Thanks for joining, everyone. I had a great time.